In this video, we're going to find derivatives using basic differentiation rules, just a review of our rules so far that we can use. The derivative of any constant is 0. The derivative of anything with respect to itself is 1. The derivative with respect to x of x to the nth power is equal to n times x to the n minus 1. This is called the power rule. I also have a sum and a difference rule that I'm going to write together here of f plus or minus g of x is going to be equal to f prime. Let's make these functions of x. Keep the sign plus or minus, whatever it was in the problem. G prime, just differentiate each piece. I also have a constant multiple rule that says that if I have a constant multiple times a function here, that this is c times f prime of x. We just learned about the product rule. And the quotient rule. We're going to be able to use those as well in these problems. I may not have said this in the video for the quotient rule. I talked a lot in the product rule about how order of multiplication didn't matter and order of addition didn't matter, and there were lots of different ways to write the product rule that were correct. Order of subtraction does matter, so you have to have this first part be the derivative of the numerator and the second part be the derivative of the denominator. It doesn't matter whether you write v before u prime or u before v prime, but it is important that you differentiate the numerator first and then subtract, differentiating the denominator, right? So that's important in the quotient rule because order of subtraction does matter. So just wanted to make note of that since I don't know that I explicitly said that in our last video. Let's go ahead and start our mixed practice here for basic differentiation rules on number 31 in the textbook. And your instructions just tell you to find the derivative of the function, state which differentiation rule or rules you used. These are the rules that we're talking about to find the derivative. So number 31 is f of x is equal to x cubed minus 3x times 2x squared plus 3x plus 5. And that's too much effort for me to expand that and make a polynomial to use the power rule with the sum difference rule. So I'm going to write this as u times v to use my product rule instead of my just basic power rule. So f prime of x is going to be u prime v plus v prime u, where u is equal to x cubed minus 3x, and v is equal to 2x squared plus 3x plus 5. U prime is 3x squared minus 3, and v prime is 4x plus 3. I'm going to make my substitutions now into f prime of x. U prime is 3x squared minus 3. times 2x squared plus 3x plus 5 plus 4x plus 3 times x cubed minus 3x. So f prime of x, 3x squared times 2x squared is 6x to the fourth. 3x squared times 3x is 9x to the third. 3x squared times 5 is 15x squared. Negative 3 times 2x squared is a negative 6x squared. Negative 3 times positive 3x is negative 9x. Negative 3 times positive 5 is negative 15. 4x times x cubed is 4x to the fourth. 4x times negative 3x is a negative 12x squared. 3 times x cubed is a positive 3x cubed. And 3 times negative 3x is a negative 9x. And we're adding everything together, so I don't need to change any signs here. F prime of x is equal to 6x to the fourth plus 4x to the fourth is 10x to the fourth. 9x cubed plus 3x cubed is 12x cubed. 15 and a negative 18 is a negative 3x squared. I added the negative parts together first to make the problem easier for me. Negative 9 and negative 9 is negative 18x minus 15. So, and again, we used the product rule here. Okay. Let's look at number 35 next. Number 35 says f of x is equal to x to the third plus 3x plus 2 over x squared minus 1. And there's no nice way to factor the numerator to cancel any common factors, so I'm going to leave it as is. Call this u divided by v. So f prime of x is going to be u prime v minus v prime u all over v squared, where u is equal to x cubed plus 3x plus 2, and v is equal to x squared minus 1, which makes u prime equal to 3x squared plus 3, and v prime equal to 2x. So f prime of x is equal to 3x squared plus 3 times x squared minus 1 minus 2x times x cubed plus 3x plus 2 over x squared minus 1 quantity squared. F prime of x is equal to 3x to the fourth minus 3x squared plus 3x squared minus 3 minus 2x to the fourth minus 6x squared minus 4x all over. Leave this alone. Hopefully one or more of the I'll actually write this as x plus 1 squared times x minus 1 squared, because x squared minus 1 factors. Hopefully some x plus 1s or x minus 1s or both show up in the numerator where something can cancel. F prime of x is equal to 3x to the fourth minus 2x to the fourth is 1x to the fourth, negative 3x squared and positive 3x squared, then minus 6x squared. And we have a minus 4x and a minus 3. So this is over x plus 1 squared, x minus 1 squared. This was number 35 there. And that's done. The top is not factorable. So that's it. All right, let's look now at the next one is number 37. Number 37 says that f of x is equal to x squared minus x minus 20 over x plus 4. So this one actually does factor into x minus 5 times x plus 4 over x plus 4. And we can cancel that. So this becomes f of x is equal to x minus 5, as long as x is not equal to a negative 4. It won't be differentiable at negative 4. There will be a hole in the graph there. F prime of x is going to be equal to 1, as long as x is not equal to negative 4. And I used the power rule here. So let's go ahead and see. I bet they used the, oh, they did use the power rule. They did just what I did. Now, if you had used the quotient rule here, then you would still get the same answer. It would just look a little different. Let's see what would happen if we jumped into this problem without factoring. So method 2 here. If we said that u is equal to x squared minus x minus 20 and v is x plus 4, then u prime is 2x minus 1 and v prime is equal to 1. F prime equal to u prime v minus v prime u all over v squared is 2x minus 1 times x plus 4 plus 1 times x squared minus x minus 20 over x plus 4 squared. F prime x is equal to 2x squared plus 8x minus x minus 4 plus x squared minus x minus 20 over x plus 4 squared. See, this is not plus, this is minus. And minus means this is minus plus plus. So this is f prime of x is 2x squared minus x squared is x squared. This is plus 9x, sorry, plus 8x. So we have negative x plus x is 0, plus 8 is 8x. And then 20 minus 4 is 16 over x plus 4 squared. But this numerator is x plus 4 times x plus 4. And x plus 4 squared is also x plus 4 times x plus 4. So these all cancel to make a 1, which is the same answer. It was much easier to use the power rule up there. We prefer to use the power rule when possible. All right. Let's clear our canvas. 39 is written as g of t is equal to 2t to the third minus 1 quantity squared. And we do not know something called the chain rule yet. So we're going to have to expand this out, or we're going to have to use the product rule. So I think we're going to expand it and use the, actually they do want us to use the product rule. So I'm going to write this as 2t cubed minus 1 times another 2t cubed minus 1. And that makes this equal to u times v. So that makes g prime of t equal to u prime v plus v prime u, where u is equal to 2t cubed minus 1. V is also a 2t cubed minus 1. U prime is 6t squared, and v prime is also 6t squared. So g prime of t is 6t squared times 2t cubed minus 1 plus another 6t squared times 2t cubed minus 1. G prime of t is going to be 6t squared plus 6t squared is 12t squared times 2t cubed minus 1. And they leave it just like that in the book and say that they used the power or product rule. Okay. Number 43. F of x is equal to x minus 2 times 3x plus 1 over 4x plus 2. Now, 4x plus 2 has a common factor of 2. That would leave me with a 2x plus 1, but there's no 2x plus 1s on the top. There's no reason for me to factor here. So what I'm going to do instead is I'm going to try and write the numerator as a single function and the denominator as a single function and use the quotient rule. So let's go ahead and rewrite f of x as x times 3x is 3x squared. And then x times 1 is x minus 6x minus 2 over 4x plus 2 is 3x squared minus 5x minus 2 over 4x plus 2 is my u over v. So f prime of x will be u prime v minus v prime u all over v squared. U is equal to 3x squared minus 5x minus 2, and u prime is equal to 6x minus 5. V is equal to 4x plus 2, and v prime is equal to 4. So that makes f prime of x equal to u prime times v minus v prime times u all over v squared. F prime of x is equal to 24x squared plus 12x minus 20x minus 10. Then a negative 4 times 3 is a negative 12x squared. Negative 4 times a positive, or times a negative 5 is a plus 20x, and a negative 4 times a negative 2 is a positive 8. It's all over, and we want 4x plus 2 quantity squared. Let's go ahead and scroll down to make a little bit more space here. Give it a second to reset. There we go. F prime of x is equal to 24x squared minus 12x squared is 12x squared. 12x minus 20x, that's a negative 8x, plus 20x, that's a 12x. And then negative 10 plus 8 is a negative 2 over 4x plus 2 quantity squared. My numerator has a common factor of 2, but it's not going to factor into anything with a 2x plus 1. So I can just leave that, and we used the quotient rule here to differentiate. Okay. I think that's the end of our mixed practice problems. We'll come back next time and find the equation of the tangent line. And we're going to be using the product and quotient rules to do that. So remember that tangent line problem is a big application idea in calculus. So we're going to come back to do that specific type of problem again, now that we have learned new types of derivatives. So see you for the next video.